The key to answering this question is to use the definition of what sine of an angle is, the opposite over the hypotenuse, in a right triangle, to create a right triangle, find the remaining side, and then figure out all of the remaining trig functions. So we know that if the sine of theta is 3 over 7, and the opposite side is 3, the hypotenuse is 7, and we can use Pythagorean theorem to find the adjacent side. So in this case, we can say that a, the adjacent side squared, plus 3 squared, the opposite side, has to equal 7 squared, the hypotenuse. So a squared plus 9 is going to equal 49, and then if we subtract 9 from both sides, we'll have a squared being equal to 40. If we take the square root of both sides, we'll have a being equal to the square root of 40. We know it has to be the positive version, and that will simplify to 2 root 10. So now we know that our adjacent side has a length of 2 times the square root of 10, and we can figure out all of our remaining trig functions. So we know that the cosine of theta is going to be the adjacent side over the hypotenuse, so that will be 2 root 10 over 7. We know the tangent of theta is going to be the opposite side over the adjacent side, so that'll be 3 over 2 times the square root of 10, or 3 root 10 over 20. We know the cosecant of theta is going to be the reciprocal of the sine of theta, so that'll be 7 over 3. We know secant of theta will be the reciprocal of cosine, so that's going to be 7 over 2 root 10, or 7 root 10 over 20. And we know that the cotangent of theta is going to be the reciprocal of the tangent of theta. So that's 2 root 10 over 3. And those are our final answers.